Good morning everyone, welcome back to Question a Day. Today we will be answering the July the 19th question on tangents. So we have a curve with equation y equals x squared plus 4 times x minus 3 all divided by 2x. And we're given this condition x is not equal to 0. Now a reminder of what that means, it's just that if we put 0 into this, it will kind of break things. If you imagine putting 0 into that divide by 2x, that'd be a divide by 0, and we don't like those, if you remember. But other than that, it shouldn't be something to worry about. So, we've got this equation, and first off we want to find dy by dx in its simplest form. Okay, so we have y is equal to x squared plus 4, x minus 3, divided by 2x. We can't apply our differentiation rule yet because we don't have a string of powers. We've got several strings of powers multiplied together and divided. So we're going to have to do a little bit of rearranging first, and then we'll be able to differentiate it. So first off, we're going to expand these two brackets. Now I've got an x squared and an x. We'll multiply those two together. That makes an x cubed. An x squared and a minus 3. It's going to be minus 3x squared. We get a 4 and an x. That's going to give us plus 4x. And a 4 and a minus 3. That's going to give us minus 12. And this entire thing is still divided by 2x. So now we need to do this division by 2x. We can't differentiate this yet because we've still got this division. So x cubed divided by 2x, that's going to be x squared divided by 2. Minus 3x squared divided by 2x, that's going to be minus 3x divided by 2. 4x divided by 2x, should be fairly simple to see that that's 2. And minus 12 divided by 2x, well, that's going to be minus 6. Now this is going to be our 1 divided by x. And we should recall that we actually want to write this as x to the power of negative 1. So then we can differentiate that using our rule. Okay. So now we're ready to find dy by dx. We see x squared divided by 2. Well, we'll take the power down. We get 2 times x. We'll leave the so we'll reduce that power by 1. So 2 goes to 1. Divided by 2. Minus, well, this x is just going to go. So we can imagine 1 going to the front and the power here being 0. But any x term just is going to disappear and be left with 3 over 2. We remember that any constant, when we differentiate it, is going to become 0. So that 2 goes away completely. And then minus 6x to the minus 1. Just note this here, minus 6x to the minus 1. Well, we'll bring this minus 1 in front. So we get minus 6 times minus 1 x. We'll reduce this power to minus 2. Tidy this up a bit. So 2 times x over 2. We just get x. Take 3 over 2. And then that's going to be plus 6x to the minus 2. And there is our answer for this one. Right. So we have that. Next, we need to find the tangent. So here's our curve. We want to find the tangent at the point x is equal to negative 1. So here's where we want to use our kind of tangent finding process. So the best way to do this is it's a 3-step process. The first step is we're going to think about our point. Our point is where x is equal to negative 1. We need a y coordinate as well. So we can put that into our equation at the top. And if we do that, we get that y, well, that's going to equal 1 plus 4 times minus 1, take 3, all over negative 2. That's going to be 5 times minus 4, which is negative 20, over minus 2, or 10. So our point is negative 1 and 10. Again, you can do that in your calculator if you so wish. The next step is the gradient. So that's the next part to work out. Now we've already worked out our dy by dx. If you remember, dy by dx tells us the gradient at any point on the curve. So we want to find dy by dx when x is equal to negative 1. Now a way you can notate this is you can draw a little line down like that and put x equals negative 1. Or you could just write dy by dx when x is equal to negative 1. Now we'll substitute this in to our dy by dx that we had here. So we're going to get x becomes negative 1, minus 3 over 2 is unchanged, and we get plus 6 times x to negative 2, well that's going to be plus 6 times negative 1 to the minus 2. And negative 1 to the power of minus 2, well that's just going to be positive 1. So this becomes negative 1, take 3 over 2, plus 6 times positive 1 is just 6. So we'll finish this off, so that's 5, 7 divided by 2. That is our gradient. The last step is our line. We're going to write out our equation of the line, which is y minus y1 is equal to mx minus x1. Now we should always be using this form in A level, because it's much easier to work with than our original y equals mx plus c that we know from GCSE. So now we can substitute into this all the information that we know. I know what x1 is going to be. It's going to be this minus 1 we have here. I know what y1 is going to be. That's going to be our 10. I know what our m is. It's 7 over 2. So we get y take 10 is equal to 7 divided by 2 of x take minus 1, which would just be plus 1. And the minus and the minus cancel. And we can just expand this. We're asked in the question, you see here, to give it in the form of ax plus by plus c. Well, we just want to rearrange this to get those integers that we wanted. So, first easy step, probably get rid of this divided by 2 that's causing problems. So we get 2y take 20 equals 7x plus 7. And we want to shift it all over to one side. So we get 2y take 7x, take 20, take 7. That's going to be minus 27 is equal to 0. And there you go. Just before we run out of space, there is your answer. That's all for today. I'll see you tomorrow.